Hey, welcome to our lesson here. My name is Mr. Kelly and I'm an Algebro. I'm going to teach you a little bit about ratios and rates in this first lesson. Now, it should be review, right? Let's start with an example here. We're talking about Mr. Brust. He's loving his cookies. He's another Algebro. His favorite, of course, is a special math cookie called an Algebrorio. I think we made that up, right? So we might do that sometimes. Mr. Brust will eat 4 chocolate cookies for every 3 peanut butter cookies. Now, ratios are when we compare 2 different quantities. And in this problem, we're looking at the chocolate cookies and the peanut butter cookies. So what I'm going to do is I'm going to drag over the numbers so we can see it. We can always draw a picture. I'll consider this drawing a picture. We're going to put in here 4 chocolate cookies. Let these represent a chocolate cookie, right? So 4 chocolate cookies for every 3 peanut butter cookies. So I'll put the peanut butter cookies in here as well. And then we'll look at our total number of cookies. How many total cookies do we have in there? We have 4 chocolate, 3 peanut butter. That's a total of 7, right? So let's get focused on the words that we can use to describe these ratios. Okay, the ratio of blank to blank is 4 to 3. Well, we know that the ratio of chocolate cookies to peanut butter cookies is 4 to 3. And so we can write it just like this. I know there's not a lot of room, so you can abbreviate if you want to, PB and CH. But the ratio of chocolate cookies to peanut butter cookies is 4 to 3. And the order is very important because I know by writing it this way, because the 4 is first, there are 4 chocolate to every 3 peanut butter. Well, let's see what happens here. The ratio of blank to blank is 3 to 4. Notice that we changed the order, right? So I need whatever the number 3 is associated with first. I need to write that first because that tells me the order at which I'm comparing. So for the second example, we would have the ratio of peanut butter cookies to chocolate cookies. That would be 3 to 4. Okay, now the next one says the ratio of blank to blank is 4 to 7. So this is getting a little bit more complicated. Not too bad though. Where does that number 7 come from? And if I go up and look at the total number of cookies, I notice that there are 4 and 3. That's 7. So when we're talking about the ratio of blank to blank, 4 to 7, well, I know that the chocolate cookies are actually, that's the part that's 4. And the number of total cookies is 7. So the ratio of chocolate cookies to total cookies is 4 to 7. So now I'm going to ask you to pause the video. We'll ask you to do this sometimes. Pause the video and do this last one here. I want you to write the ratio of total cookies to peanut butter cookies. So pause the video and do that one by yourself. And hopefully you got 7 to 3 because the total number is 7, but the peanut butter is 3. So the ratio of total cookies to peanut butter cookies is 7 to 3. Easy enough, right? So let's look at this next example, which is very similar, but it's a little bit different in 2 parts, and I'll show you where. Mr. Sullivan asked his students what they think about his video after they watch it. And for every 2 students that liked it, there were 5 students that did not like it. So the first thing I'm going to do is I'm going to notice that that's a total of 7 students. So the first 2 statements here, the ratio of something to something is, and what is this? This is a fraction. All right, this is another way to write 2 to 7. So we see we can use a fraction to represent the ratio. It just means the same as 2 to 7. So going back to this problem, what is the comparison that would be 2 to 7? Well, we know that 2 students liked it, so we can add that at the beginning. And then the 7 was the total. Okay, so that's pretty easy. So the ratio of students that liked the video to the total students is 2 to 7. Now, when we go to the next statement, I notice that we have 2 blanks again, but it says the ratio is 5 and then this colon 2. That's a little bit crazy too. That's another way to write 5 to 2. So we can look at 2 different ways to write these ratios. We can use a fraction, 2 to 7, or we can use a comma, 5 to 2. And looking back at this problem, if we're comparing the numbers 5 to 2, obviously we're talking about the students that did not like the video to the students that liked the video. And then lastly, the ratio of students who did not like it, okay, that was the 2, that was a 5, sorry, to the total number of students, that would be 5 to 7. Easy enough, right? I mean, I think you've done these before, so we're good to go. Now, this one looks a little bit tricky. It's a crazy table, and look at all those numbers. We have the number of free throws, number of 2-pointers, number of 3-pointers. We have a total column, and all these numbers involved here. So don't let all of the numbers get too crazy and worry you too much. Let's read what it has to do with this problem here. The following table represents the number of baskets made from a basketball tournament that the Algebros played in. By the way, there's 4 Algebros. Here they are. Mr. Bean, Mr. Brust, Mr. Sullivan, Mr. Kelly. Use the table to find the given ratios. That's all we got to do. We got to look at the table and we got to find the given ratios. That's not too difficult. So the first one, find the ratio of Mr. Bean's to Mr. Brust's 3-pointers. So all I need to do is look here where it says 3-pointers, and I can look. Mr. Bean, it says, had 2 3-pointers. Mr. Brust had 0. So let's write that out. So here's how I can write that out using words. 2 to 0, and I put Bean and Brust. Always good to include those units. Now, some of you are like, what about if I want to use a comma or a colon? There's the colon. 2 3-pointers for Bean to 0 for Mr. Brust. But what if I want to use a fraction? All of these are perfect answers. You don't have to do all of them. You can just pick one. I'll probably just stick to words from now on. But you should be familiar with also the colon and the fraction. All right, let's find the ratio of Sully's 2-pointers to the total 2-pointers. So looking at the table here, Mr. Sullivan, that's Sully, his 2-pointers, that's 2 to the total number of 2-pointers. Well, here's the number of 2-pointers. The total number would be at the bottom of that column, so it's 24. So I could write that out like this, again with my units, just to make sure that I'm being very clear. And lastly, explain what the ratio 11 to 8 could mean. Well, here's the thing. That could mean a lot of different things, because look, I see 1 8 in here. I see another 8, another 8. Oh my goodness, where's the 11? 11? There's only one 11. So it must be comparing the number of 3-pointers to, and we have some options, and they're all right. I'm going to compare it to the number of free throws. Let's write that out. So I'll write it out like this. It could be comparing the number of 3-pointers total. Maybe I should say the total number. That would be better, huh? The total number of 3-pointers to the total number of free throws, including that word total. But it also, if you looked at this table and you said, well, it's also the total number of baskets Mr. Bean made. So you could compare the total number of 3-pointers to the total number of baskets Mr. Bean made, but honestly, it probably is comparing these two. That makes more sense. And so that's how you can use a table, and you can figure out some of the ratios based off of a table. And so the last part of our lesson today talks about rates. And what rates are is when you have a ratio between 2 or more quantities and you're comparing them, and usually they're different units. All right, so let's write that out. A rate expresses a relationship between 2 or more quantities, and they're used to compare. So Mr. Sullivan runs 15 miles in 3 hours. How far can Mr. Sullivan run in 1 hour or 2 hours, or maybe they ask you 4 later. So let's figure this out a little bit. If he runs 15 miles in 3 hours, I'm going to go down here and I'm going to put that down under the 3. It's 3 hours here in this table, so I'm just going to write a 15 right here. So one of the things we can do is complete this table, and that'll make it easy to see what the relationship is between the miles and the hours. Okay, so if he does 15 miles in 3 hours, I can divide both of these by 3, and I can figure out that he will do 5 miles in 1 hour, correct? So 15 miles in 3 hours would be the same as 5 miles in 1 hour. But once I know this, then I can say, well, if he does 5 miles in 1 hour, then he would do 10 miles in 2 hours. And also, by the time you get to 4 hours, it would be 20 miles. And let's not forget that very first one. In 0 hours, how far can he run? Well, that's easy. That's 0. Okay, so now that our table is complete, we can start to answer some of these questions. Write 2 equivalent ratios to show the relationship between time and distance. Now notice they didn't tell you which ratios you can use, so you can pick any of them. So I'm not going to use 0 to 0 because that doesn't tell us very much. But if we go to the first ratio here, 1 hour to 5 miles, that is one ratio that we can use to describe that relationship. And then I just went to the next one, 2 hours to 10 miles. And you could have used 3, you could have used 4, even 5. It's stuff off the table. Easy enough. Look at the next one. Write 2 equivalent ratios to show a relationship between distance and time. So I gotta be careful. Distance goes first. So distance is on the bottom row. Time is on the top row. So I just kept going down the columns here. I said 15 miles, that's the distance, to 3 hours. Or 20 miles to 4 hours. But again, you could have used 5 and 1, 10 and 2. Doesn't matter. Those are all fine because it just says write 2. So, any 2 will work. Now here's the part. At what rate is Mr. Sullivan running? So we need to compare the two. And ideally, we want to use 1 hour because it'll tell us for 1 hour how fast he's going. So I like to use these rates. I write them as a fraction. So we'll write it like this. 5 miles per 1 hour. And as I said, I'm going to use a fraction. If I divide these numbers out here, I get 5 miles per 1 hour. Do you hear that word I just used? Per. Okay, 5 miles per 1 hour. When we start comparing for every 1 hour, then that is called a rate. And we can tell how fast Mr. Sullivan's going. So I'm just going to look right here when the time is 1, and that's going to help us use the 5 and the 1. We can find that. We can find out what the rate is. Okay, so then we can answer questions like, how long will it take Sullivan to run 45 miles? Okay, so 5 miles per hour, that's how fast he's going, times how many hours will equal 45. This is how fast he's going per hour. It tells us 1 hour is 5 miles. So if I go 5 miles in 1 hour, how many hours until I get 45 miles? So another way to think about this is 5 times however many hours has to equal 45. And so we know this is easy math. Now the problems I've given you are all easy math because we're just getting used to the words and the terminology. 5 times 9 is 45. So we always want to answer the question with a sentence. It'll take Sully 9 hours to run 45 miles, right? Now, another way you could have figured this out is continuing this table, right? You'd have to go all the way out to 9. That's, I don't know, it's not too far, but sometimes they'll give you questions that are pretty far. So you're just going to want to take that 5 miles per hour and then figure out what do you multiply by to get to 45. And that's basically it. We're going to get used to the terminology and the words for ratios and rates. Good luck to you. Complete the packet. Make sure you check your answers. Check your answers with my answers, and then good luck on that mastery check. This is Mr. Kelly in K-Town. Remember, it's nice to be important, but it's more important to be nice. See ya!